Okay, so the first medium difficulty question for Statistical Rethinking 2nd edition. In this video and the next video, we're going to be tackling questions 5M1 and 5M2 because these deal with different types of relationships between predictor variables and outcome variables. So even though I'm answering them all together in the Colab sheet, we'll make separate videos. So the first relationship we'll talk about is spurious correlations. We'll talk about that. And in the next video, and later on in this answer on the Colab sheet, we'll talk about masked relationships. Before running any of this code, you'll need a few packages, of course. Make sure that you've installed and loaded the Rethinking package. And you may also want to install and load the DAGs package. Okay. So let's start with one. So invent your own example of a spurious correlation. An outcome variable should be correlated with both predictors, but when both predictors are entered into the model, the correlation between the outcome and one of the predictors should mostly vanish. Okay, so I have a tough time following that. But I'm going to just walk through what a spurious correlation is and give an example, and hopefully provide some things that some clarification for what's in the text. I really encourage you to watch McLaren's lectures on this. They are very well illustrated and explained there. Okay. So spurious correlations and masked relationships teach us one thing, and that one thing is, especially if we are concerned with inference, that is how predictor variables affect a particular outcome, we really need to be thoughtful about what we include in our regression. And the reason is because different predictor variables, they interact among each other. They have their own relationships, and some of those relationships can cause erroneous inferences when we run regression or any kind of statistical analysis. And so one of the tools that we can use to think our way through the regression are these directed acyclic graphs, or DAGs. Okay, now McLaren and the Rethinking book do a very good job about talking about DAGs, but if you want more, there's a very good resource by Judea Pearl. I believe that DAGs are really his brainchild, and he's written a few books. There's one very easy one for the lay public. It's called the Book of Why. There's a hard one called Causality, and then there's one right in the middle, and that's the one that I recommend. So there's a link here to an Amazon link if you're interested in buying that. I think, well, yeah. Okay. So we're gonna build some DAGs here to try to think our way through a spurious correlation. So I'm going to use R, okay, to build our spurious correlation, but you can also go to dagity.net, and in fact I'm going to pull dagity.net up here and just go through and just build a DAG in that. Okay, so here I'm in dagity.net. Okay, so if I go to launch Dagity, of course this may change by the time that you're watching this, but so if I go here, I'm given this screen. And so first I need to delete all of these variables. It just kind of gives you a default DAG, I guess, just to demonstrate what it's capable of. Okay. So now if I click anywhere on here, I'm going to click, it allows me to build a variable. I'm going to call it X. I'm just going to put it here. And I could select the type of variable I want this to be. This isn't necessary, but I will here just because. Okay. And now I'm going to create another one called F, and F will here stand for fork, and you'll see why in a little bit. Call that an exposure, and then one more for Y, and we'll say that Y is also an outcome. And if I just click 1, 2, I create a causal relationship between these variables. Okay, so this is a basic fork. That's why F, this variable, is called a fork, because it affects both X and Y, and this is a basic genesis of spurious correlations. Okay, so if you have data and this is how those data are related in the real world, you will get a spurious correlation. So let's talk about that. Okay, so I'm going to build that same DAG here in R. Okay, so I need to load this package called Dagity. Okay, I also need to load the Rethinking package because like draw, DAG, and maybe coordinates are part of the Rethinking package. Okay, so here is my DAG. Okay, so I have X and Y, and they're both being affected by F. Again, this is called a fork structure, and it is the cause of spurious correlations, right? So what is happening here? So F is affecting X, it's causing X, or it's a cause of X, and it's also a cause of Y. Now, because of that, there is a relationship between X and Y. It is not because X causes Y, it is because both X and Y have a common cause, which is F. Now, if we now if I go to regress Y on X, which we'll do in a little bit, we will see a relationship between X and Y. And we may conclude, depending on the system, that somehow X is causing Y. Okay? But of course, we know that's, well, in the example that we'll make, we'll know that that's not the case. Okay? And so what we would have to do to remedy the situation is to also include F in our regression. All right? And so, and then that will fix everything. So let's come up, so we're going to do an example here. So my example is to take F as being temperature, okay? X as being ice cream sales, and Y as being the number of heat-related medical emergencies in a city or whatever, okay? So I'm going to create some data. So I have F, and F is just a vector, a normally distributed vector of temperatures. So I'm going to have 1,000 temperatures that have a mean of 60 degrees and a standard deviation of 15, right? So we're getting up over 100 and getting down pretty cold, all right? And now I'm making X, okay? So again, F is a cause of X. I'm making X a function of F, and here I'm just multiplying it by 1. So ice cream sales and whatever units we're using is just collinear with F, okay? Plus this random noise bit here. So this is just to add a little bit of noise in the data. It's not much, but it's not important for our purposes here. Okay, and now similarly, I'm making Y. Again, Y is being affected by F, by the fork variable. It is also a function of F, right? It's 2 times F plus some random noise. Okay. Now I'm going to regress with the lm command. This is a base command in R, so I apologize for not using the rethinking notation here, but it's not important for our purposes. So this is a frequentist model, not a Bayesian model, but that's okay here. But I'm going to regress Y on X, okay, Y on X, and then I'm going to look at the output. Okay, and so this is what the output looks like. I've never ran the lm command, so let's just run through that. So first we have what our regression was. Y was regressed on X. Okay, we'll ignore that for right now. So this is the coefficients. So the coefficients are the alpha and the beta terms in our regression as we've come to be familiar with them. So the intercept here is whatever it is. Okay, and then we have X, and so really this is the coefficient for X, the beta X of the regression. Okay. And we see that we have an estimate of about 2, which makes sense because, well, Y is twice the value of X, okay? And if you're familiar with p-values, it's highly significant, okay, whatever. In other words, there is a very strong relationship between X and Y. And so again, you know, our model, or our example is a little bit silly, but in a more kind of opaque system, you might conclude that X causes Y, which would here be akin to saying that somehow ice cream sales are driving heat-related medical emergencies, which in this case is, again, obviously a bonkers conclusion, but there are other systems in which it's not so clear that X causes Y would be a bonkers conclusion. Okay, so now we can fix this problem here if we include F in the regression. Okay, so when I include F in the regression, all of a sudden the relationship between X and Y, so the relationship is flowing along these lines. It doesn't care about the direction of the arrows. It's just flowing from X to Y. All right. But and that's what the regression is picking up. But if I condition on F, it is as though the association, if association was like a surge of power that went through these power lines, these arrows, by conditioning on a variable, on a fork variable, we are going to stop that flow of association. So I'm going to find, I could find that X is associated with F, and that F is associated with Y. But by including F in the regression, I am blocking the flow of association between X and Y. That's one way to think about it. Okay. So again, so now I have the same regression, but I've fixed it to also regress on F, and that's how I write a model in LM. I say, what is the outcome? Regress it on these variables here. Okay, so I'm going to run that, and I'm going to get a similar summary as above. Okay, so try to get both of these on the screen. So again, here's my call. Here's the formula that I used. Okay, regressing on X and F, and then here are the coefficients for both X and F. And now we notice that the coefficient for X has been driven to 0, and there's a very weak relationship, so a very weak p-value. Okay, but the relationship between F and Y is highly significant, and it's about what we would expect. It's about 2, right? Why is it about 2? Well, it's about 2 because Y is twice of F, okay, plus some noise. So anyway, so that is our example for a spurious correlation. Again, in the next video, we'll deal with 5M2, which deals with a different relationship, and that is masked relationships.